Okay, last lesson for this Friday. 2 things that I need to go over, SOHCAHTOA and the idea of labeling right-angled triangles. In geometry, well actually, in algebra, what do we call unknowns most of the time? We usually called it x. But in geometry, instead of x, for unknown angles, we use the sign theta. It's an oval, and it's got a line through halfway. So it's just accepted in maths. It doesn't matter whether you like it or not. Someone more important than you decided that theta is what we call angles in maths. I don't get a choice. I'm following what maths has decided for me. In right-angled triangles, there's always 3 sides. The first is the hypotenuse. What did we say about the hypotenuse? It's always across from the right angle. So the hypotenuse in this triangle would be B and C. What do you notice about that? It's on the other side of the right angle. The opposite side in a triangle is across from the angle. So if my angle in this triangle is here, which side of that triangle is going to be opposite of the angle? AC. That is opposite. So let's label them. Hypotenuse, opposite, and the adjacent side, ADJ. In real life, the term adjacent means next to. So our friend here is adjacent to me. Our friend over there is opposite to me. So this leftover one is adjacent. Hopefully you see this exercise, 3 questions worth a lolly, that requires no thinking, no maths whatsoever. You shouldn't need your calculator to work out where the hypotenuse of a triangle is, what side is opposite the angle theta, and the last leftover side is adjacent. Can you get that note down? Those notes down, please, in the first example. Free. Don't talk yet. I'll give you a minute for that. Then I'll go over trig ratios, and then we're done for today. All right? In that space, wherever in your... This is the same as your booklet. Or you could write it in your maths book if you wanted.
Is most of the stuff, is like the entire subject of general maths just based around like real life applications that most people use?
Yeah, that's a good question for our mate over here. If you wanted an idea of what general maths is like, it's basically a repeat of year 10 maths. No word of a lie. I'm teaching the exact same things. If you wanted to question me about whether I'm lying or not, look at the videos I uploaded this year when I taught year 11 general maths. Taught exact same things. Actually, in year 10 maths, we're not even doing... in year 11 general maths, we do not do trigonometry. We just do measurement, and you do an assignment on it. In essential, you do measurement, but easier. You also tell the time. You told me the numbers between 13 and 15. You tell me what a pentagon is. Yep. Someone at SACE decided that's worth money. Right? I think you're solidly general. You're solidly general. I think you could try methods, but it'd be a struggle.
What the use of each mathematical subject
methods is very abstract. So the only people that should really be doing methods is if you really want to be an engineer of some sort. But my maths, the methods that I teach, finance, measurement, trading maths, it's all applicable in real life. There's only like maybe one topic in all of year 12 and all of year 11 that isn't necessarily applicable to real life. But that's because SACE decided. I can't decide for myself. Shh, boys. All right, let's move on. I gave you that time. The only other thing you need to get is this. You may have heard of SOHCAHTOA before. Where does SOHCAHTOA come from? Because the trig ratio, sine of theta, is opposite divided by hypotenuse. The cosine of theta is adjacent divided by hypotenuse. And tan of theta is opposite over adjacent. If you look at the first letter of all of those things, S, O, H, where does that go? That's SOH. C, A, H, that's Ka. And T, O, A, that's Toa. So in maths, we teach you SOHCAHTOA, so it's easy to remember these trig ratios. Get the ratios down, please, and then I'll show you what we're asking you to use them for today. It's labeling again, not even maths yet. I need you to grab my bag from downstairs later to get the switch, because I think you'll finish. There's no actual maths here, you're just labeling things in these last two, so you get your 4 lollies and then you can see. So these last 3 questions that I'm asking you to do in 24 is to find sine theta. Sorry, I need to do it in purple. Sine theta for this triangle. In your notes, you just got that sine theta is opposite over hypotenuse. So let's look at this triangle. Which number is the hypotenuse? 5, 3, or 4? 5. Well done. Which one is opposite the angle theta? Opposite. The last one left over is your adjacent. So sine theta is opposite over hypotenuse. So it's going to be 3 over 5. That's it. No working out. You just leave it at that. Sine theta is 3 over 5. Cos theta. Cos is adjacent over hypotenuse. Which one did we just label adjacent? 4 over... Which one did we just label was the hypotenuse? 5. Done. Tan theta. Tan theta is opposite over adjacent. Which one did we just label opposite? 3. Which one did we just label adjacent? 4. You're done. Do you need the calculator for that? You are just looking and replacing words with numbers. Please do that. You get your 4 freebie lollies today, because this is setting up for us to do maths next week. You need to be able to label them so that you can do that maths. Okay, I'm going to stop there.